Good morning everybody. My name is Kiran. Now I am going to explain about nonlinear data structures. So first of all, what is a data structure? So it is a particular way of organizing data and storing in a computer's memory. And basically actually why these data structures are used to solve what sort of problems. Basically these problems can be divided into three categories. First one is real-time data storage. Basically, these data structures are used to store the real-time data, like physical entities, like a financial transaction made by the bank, doing one check to a user, or or a physical record of a human being, and also like a inventory record of a part of a car or a grocery item in a shopping complex. Like these data can be stored, these physical data have to store, and for this problem we will use these data structures. And data structures can also can be used like a problems real world modeling means for example in a bank the customers are waiting in a bank counter by line, so this is it can be modeled as a queue, right? And one more classification is programmers tools. Here actually not all the data storage structures are used to access the data. Some of the data structures are used by the programming itself, not by the users. So these data structures can be acts as a tools for the programmers to do some other operations. And finally, actually these data structure can be classified as a two types. First one is primitive and the second one is non-primitive. Primitive data structures are defined by predefined by the programming languages, and we can call as for example integer, character, float, double and string. These are primitive data structures. And one other type is non-primitive data structures. These data structures are not defined by the programming language. These are defined by the programmer. And this type of data structures, in this, the data variables will be referenced by a pointer. These are the reference variables. So using these reference variables, these data structures are defined. And these non-primitive data structures can be classified again into two categories. First one is linear data structure and another one is non-linear data structures. And in linear data structures, we know that, for example, arrays. So these are in linear data structure. The data will be stored in a contiguous memory locations. Whereas non-linear data structures, the data will be stored in a hierarchical manner, like a tree, for example. Okay. And in linear data structures, again it will be classified into two categories. First one is linked list and another one is non-linked list. In non-linked list, for example, arrays, stack, queues. So in this linked list type, the data will be stored in a sequential manner. And another linked list, here in linked list data structures, all the variables will be referenced by a referencer variables. Here mainly the pointers will come into the picture, and and it can be classified into single and double linked list. In single linked list, every data item will be referenced by a node, and that node having one data value and reference to the next location. So in this single linked list, so every node will reference to the next node. And second one is the double linked list. In double linked list, each node will be referenced to the previous and the next location of the memory. So here the two pointers will be used to denote a one node. And next we are going to the non-linear data structure. Here there are two types, basically trees and graphs. In this we have different types of data structures we have available. So from this data structure, which type of what data structure we have to select, that depends on your application. Mainly we have mainly two concerns. First one is time complexity and space complexity. So based on these two criteria, we have to select which data structure we have to going to use in our application. So, and now the trees. these are the trees are nonlinear data structures. These trees having the more advantages compared to other data structures, and having the it is a combination of ordered arrays and the linked list. So the advantages of these ordered arrays and the linked list as combined, and these trees having those advantages. First one is the ordered array. Ordered array is, it has the advantages of finding an element in the entire array. So basically it is very fast compared to all other data structures. For example, suppose one ordered array is there, we have to find one element. So the searching process will start from the center itself. So if the target, the value which we are going to find, it is greater than the center value, it will goes to the left, otherwise it will be left. So by this way it will narrow down the search space, then it will be fast down the searching process. But coming to the inserting or deletion of an element in this array, it will be more time consuming process. For an example, this is one ordered array. So here the elements are ordered like 1, 2, 3, 4, 5, 6. Suppose if I want to place, if I want to insert an element 6 in the middle itself, then first we have to search the element where it should be placed. Then again, the element, all the elements we have to move to the either here the right side, and here 2, 3, 4, 5 will come, and the 6th element will be placed here. So this is a multi-move process. So it will take more time, either insertion or deletion. So these are disadvantages of ordered array. And next, coming to linked list. In the linked list, searching an element is a time consuming process, whereas coming to inserting or deletion of an element is a speedy process, because in the linked list all the elements will be linked by the nodes by using the reference variables. So insertion and deletion process will be made by just changing the pointers, and we can do that operation. But searching an element is very time consuming process, because it has to traverse entire the structure from the beginning to start. You have to compare the element, each and everything, and such that we can search the element. So these advantages of linked list and ordered array, these advantages are combined in the trees. So trees having both finding an element in a speedy, quickly, and insertion and deletion operation also we can do as quickly. Here fundamental tree structure is a binary tree. So this is one example of a binary tree. So it is actually tree is a collection of nodes, combination of an edges and nodes. So these are all circle, these are all nodes, and this is the path. It is an edge connecting between the nodes. So mainly this is a root node, the top one is. So every tree has a root node, and for every node there is a only single path from root to from root to a particular node. If having multiple paths, then it is not a tree. See here, from A to A. So to go to H node, A, B and D and H. Otherwise A, B, E and H. Two paths are there. This is not a tree. So there should be only one path between the root node to other node. And the below one, these are all leaf nodes. So leaf nodes are having no. So these are root node, and B and C are the child nodes. Suppose B, D, E. D is the left child and E is the right child. So this is the B is the parent of D and E. Okay, for any node having an edge going upwards, so for that node the D is called the parent of H. In the same way, the edge coming down to the E, then E is called the child node of B. So, and already I told that this tree is a hierarchical structure, and having this tree having the depth of 4, and subtrees. So this part we can call as a subtrees, because this is a root node for this subtree, and Ij are the left hand child nodes of the F. Okay, now I will show you one example about the tree, how the advantage of ordered array and the linked list which are included in these structures. First one, the advantage of this ordered array is what finding an element is a very big process. I will show you in this tree one example. Now I have to find one element in this binary tree. So now I have to find the value, key value as 57. So now the finding process will start now from the root node itself. First it will compare the 57 value with the root node which is having the value 63. Now the key value is less compared to the root node, then it goes to the left side. Okay, and again that 57 value is compared with this 27 value. Now the key value is greater than 27, then it goes to the right side. Again it compares with the 57 with the 51. Now 57 is greater than 51, then it goes to the right side. Again it will compare the key value 57 with the 58. The key value is less than this 58, then it goes to the left. So here the matching is there. Now it finds the key value is 57. So, and the next is the advantage of linked list is what inserting and deletion of an element in the structure. So I will show you one example same. So this is one structure. Now I have to insert one element 45 in this structure. So for insertion and deletion operation, again the first step is where that elements we have to keep it. So that's first we have to select the location where it should be kept. So for that we have to find a place, then again we have to insert. So first the value is what 45. Again the same the key value is compared with the root node 60. The 45 value which is less than, so it goes to the left side, and again it compares 45. So the key value is greater than 40, then it goes to the right side. So now 50. At this node there is no children's. So the 45 element is less than 50, then it goes to the left, right. So in the left location, the key value 45 it should be inserted. So for the deletion also the same operation will do. So this is the main operations of the tree, and it concludes that the small discussion about the nonlinear data structures. Thank you.